Hey guys, welcome to this video on kinematics. So in this video, I'm going to be walking through the skills you need to be able to complete level 2 kinematics for level 2 calculus. So it's just... Alright, to start, kinematics is the study of motion. So basically, there isn't that much physics in the standards. So for those who don't like physics, that's good news for you people. So it's basically mainly focused on the differentiation and integration. So it's just applying the integration and differentiation depending on what the question is asking you, of course. And every year there's at least one exams question dedicated to kinematics. This is true for like 95% of the time. Okay, so like kinematics is a pretty popular topic. It's pretty much quite a lot of merit and exams questions that for kinematics that NCA offers. Alright, so we're going to start off with the three possible variables in the kinematics. So the three variables that you will come across in the kinematics is the acceleration, which is denoted by the little a, the velocity, which is denoted by little v, and the displacement or distance is denoted by s. Okay, you might think that s is a bit weird since you might think distance is d, but they just decided to use mathematicians decided to use the s to denote the distance. So the best thing to do in your exams is probably to use s instead of the d. Okay, just in case the marker decides to penalize you for using the incorrect variable. So just remember distance is s, not d. Okay, so basically in kinematics we'll be focusing on going back and forth between these three variables. So going back between acceleration, velocity, and displacement. Okay. Alright, so if you do the integration, you'll remember that you'll have the plus c at the end. So in kinematics, what the plus c normally means is the what is the initial of that variable. So for example, if I'm integrating from the acceleration to the velocity, and I'm integrating, and then the question tells you that the initial velocity was 5 meters per second. So that means that there is an equation for the velocity on top of the 5 meters that we started off with. Okay, so basically that 5 meters per second is just a shift up or shift down of the graph. So the up and down shift of the graph. So basically what was the variable at the start? So when t equals 0, what was my variable? Alright, so you might be seeing this slide, but like, what the heck? This is just the easiest way to remember when to differentiate and when to integrate. So it's the I'm very sexy rule. Yeah, just so you know, I'm actually not. Okay, just so you know. So to remember how to integrate or differentiate, you can use the I'm very sexy rule. So it's very easy to remember, which is good. So I means to integrate. A is acceleration, v is velocity, and s is distance. So therefore we can say we're going to integrate from acceleration to velocity to distance. And I've just got a little diagram here, poorly drawn, but yeah. So acceleration, you're going to integrate to velocity, and if you integrate again, you'll get the distance. And that actually applies for the opposite way as well. So the opposite of integration is differentiation. So you can also say I can differentiate from distance into the velocity function, and then I can differentiate again from the velocity back to the acceleration. So basically it goes both ways. Okay, so integrate is the opposite of differentiate. So basically how this works. So there's a better explanation of what we just saw on the last slide. So from basic physics, we know that the speed is equal to the change in distance over change in time. That's denoted by the little triangle. If you guys don't know, it's like the triangle. Change in distance is triangle D over triangle T. Okay. So that's what it means in the physics. Okay, this is a basic physics. Okay, it doesn't get much harder. Okay, so we can rewrite this equation as speed is the derivative of distance over the derivative of time. So basically d is the derivative, of course. So basically what we're saying is the derivative of the distance with respect to the time will give us the speed. So for example our distance is let's just say 4t, let's say. So distance is 4t, so if we differentiate we'll get the so basically that's just the derivative of the distance over derivative of time. So basically how you write dy over dx. So what is y changing with respect to x? So this is basically what is distance changing with respect to time, okay? And in all your kinematic questions, or the variable will be time, okay? So you don't have to worry about anything else other than time, okay? So basically, that's basically how it works. So again, we can rewrite acceleration as the derivative of velocity over the derivative of time. So basically, using the same logic, we can say that if we differentiate the velocity, it will actually give us the acceleration. Okay, so basically with the same example, so for example, we have y equals to something, and if we differentiate that, so y equals to like something x, so we differentiate that, we'll get dy over dx. That's the exact same thing here. So we have for example, our velocity equals to something t, and if we differentiate that, that actually give us dv over dt. So that's basically the change in velocity over the change in time. So that's the way we explain it here. So here's the very easy way to think about it. So let's say if my acceleration is 1 meters per second, what that actually means is that I am gaining 1 meters per second with each second. So as each second passes, I will gain 1 meters per second speed. That's what the acceleration is defined as, okay? So, for example, after 5 seconds, for example, my speed will be 5 meters per second. After 10, it will just be 10 meters per second. So therefore, we can say that going from the acceleration to the velocity, we can just say if a of t equals to 1, then we can say that our v of t equals to t plus of c. So whatever t is, for example, t is 10, so therefore my velocity would be 10 plus of c. So basically, like I was saying before, c is basically what are you starting with? So what is your initial velocity? So let's model this real quickly with an example. So we can say, for example, my initial velocity was 5 meters per second and 10 seconds has passed. So 10 seconds has passed with my acceleration as being 1. So therefore, I've gained 10 meters per second on top of the 5 meters per second that I had before. So that means my speed is actually 15 meters per second. If that makes any sense. And that's the exact same thing with speed to the distance. If my speed is 1 meters per second, I am traveling 1 meters with each second. That's exactly what 1 meters per second means. 1 meter per second. I have traveled 1 meters with 1 second. So it's the exact same logic. So v of t equals to 1. Then we can integrate to find s of t is t plus of c. So that's I guess that's easier way to understand things. Okay, so I'm going to move into some practice questions here. So we're going to try some of these simple practice questions. So if the object's velocity is modeled by v of t equals to 4t squared plus of 6, find an equation to model the acceleration. So going back to the I'm very sexy rule, you're going to differentiate to find our acceleration. So a of t would just be the differentiation. So therefore a of t is just so the acceleration would just be modeled as 8t. So remember, multiply the coefficient by the power and then take the power down by 1. So the 4t squared becomes the 8t, and the plus of 6, it just becomes the 0 there, okay? We try another example. So if an object's acceleration is modeled by a of t equals to 4, and the initial velocity is 7 meters per second, find an equation for the distance. Okay, so this is where our plus c is going to come into play. So if we want to go from acceleration to the velocity, we're going to have to integrate, okay? So if we integrate here, so we have to integrate. So v of t is actually equal to 4t plus of the c. However, this time we know that our c equals to 7 meters per second, and that's because we know that the initial velocity was 7 meters per second. So I'm gaining 4 meters per second on top of the 7 meters per second I had at the start. So basically, that's why our c would be equal to 7. So therefore, our v of t will actually be 4t plus of 7. And the question asks for the distance. So if we look at the rule again, we're going to have to integrate again, okay? So if we integrate again, that'll just add 1 to the power, divide by the new power, basically. So s of t equals to 2t squared plus of 7t plus of the c. So you can just leave, for this specific question, I just left my answer as 2t squared plus 7t plus of c, okay? So we have a few more examples. So a projectile's velocity can be modeled by v of t equals to negative 4t plus of the 2. So we're going to assume that when t equals to 0, our s equals to 0. So we're going to be finding the equation for the acceleration and the distance. So if we start off with the acceleration, we're going to look back at our rule. As seen in our rule, we have to differentiate to find the acceleration, okay? So just differentiate negative 4t plus of 2. So that's basically, like I said, coefficient multiplied by power and take the power down by 1. So a of t would be negative 4. So basically, I'm losing 4 meters per second speed each second. Okay. And if we have our distance, we're going to integrate this time, okay? And integrate, so we're going to get our 2t squared plus 2t plus of c. However, the question assumes that when t equals 0, s equals to 0. And that also means that henceforth that our c will also be 0. So we can write our s of t as the negative 2t squared plus of the 2t. Alright, so another example. So a particle has an equation for its distance as s of t equals to t cubed minus 6t squared plus of t plus of the 6 there. Alright, so the question will ask us for an equation for the velocity and the acceleration. So looking at the rules, we have to going from the distance to the velocity, we have to differentiate. Okay, so if we differentiate the v of t, that'll give us the 3t squared minus the 12t plus of the 1. And looking at the rule again, we have to differentiate again for the acceleration. So our a of t will be 6t minus the 12. So that's basically the few examples on how to find an equation, how to find equations given one equation. Okay, so basically they're going to give you one equation and then they're going to ask you, for example, to find the other two equations. So that will basically an example of how to do that. And remember to always follow the I am very sexy rule in order to find out when to integrate and when to differentiate. Okay. Alright, so I'm going to go over some basic terms used. Okay, so these terms will come up in the questions, and sometimes they're not really. You have to understand what the terms mean in terms of maths. Okay, in terms of putting that language into the numbers. Okay. So for example, if someone says at rest, okay. When someone says at rest, that means I am not doing anything, and that also means that my velocity is equal to 0. So for example, if it says the object is at rest, that means the object isn't moving, and therefore v equals to 0. We also have stationary. Once again, this is more of a physics term, but for what it tells you, you should understand that also means that the velocity is 0. So for example, this object is stationary; it's not moving. We also have a constant speed. So when I say constant speed, that means this object is just moving with the same velocity. The velocity is not changing. And if the velocity is not changing, that means that it's just going to be one straight line. The velocity function is just going to be one entire straight line. So it's just not changing at all. That also means that if it's not changing, that means the acceleration must be 0. If we have a constant acceleration, okay, so that means the acceleration isn't changing with anything. So if it's a constant acceleration, then your a of t, that will just equal to an x amount of acceleration. So there won't be a t in the equation, because if there's a t, that means as time changes, the acceleration also changes. So for example, if a of t equals to 2t, then if t equals to 2, it's 4, but if t equals to 3, it's 6. So therefore, my acceleration is changing. However, when it says constant acceleration, that means it's just one number throughout. It's not changing. And that's the exact same thing for the constant velocity, okay? So it's not changing with time, so it's just equal to one number by itself. And if we have an initial acceleration or velocity or displacement, so therefore, when t equals to 0, then our acceleration, velocity, or distance will equal to an x amount, okay? And that x amount is also our c value, okay, for most of these questions. Not most, basically for all of these questions, our x value here is going to be our c value for our integrated equation. Alright, so we have decelerating. I'm pretty sure I might have spelled that wrong, but decelerating, that's when the acceleration is less than 0, so it's slowing down. Acceleration is less than 0. So as time increases, my velocity will decrease. Accelerating, that's when the what am I doing? Okay, so accelerating, that's when the acceleration is greater than 0. Okay, that means as time increases, the velocity will also increase. Okay, so this just basically covers this is a bit wider range of what the questions might come up to be, but this is just an idea of some of the terms that could come up in the exam. Not not definitely will come, but might come in the exam. So it's important to get on top of these and understand what they mean. Especially for these, I don't want you to memorize these like, oh, I'm going to memorize at rest is 0 or this is this. I want you to more to understand exactly what that means, okay? So exactly what constant acceleration is, or exactly like, I mean like as understanding what it is instead of just memorizing it. So if we have a basic question here, I have no idea what happened to the transitions, but sorry about that. So Kevin is traveling through a rainforest and the terrain is unpredictable, therefore his speed is constantly changing. He starts from rest and travels through the forest where his acceleration is 3t squared minus 6t minus 6, where t is the time in minutes. So we're going to find the velocity after 5 minutes. Yeah, once again, I apologize. I don't know what happened to the animations I did for this part of my slide, but apologies. Okay, I'm pretty sure that won't happen for the next slide, hopefully. Fingers crossed. So just ignore everything at the bottom for now. So for example, we're going to start by finding the equation for the velocity. And looking at our rule, we're going to integrate here. So therefore, our v of t will equal to t cubed minus 3t squared minus 6t plus of the c. However, we know that when t equals 0, v also is 0. And therefore, our c is 0. Because the question tells you that Kevin starts from rest. And if something starts from rest, that means it's starting with a velocity of 0. And if it's starting from a velocity of 0, as we can say, the initial velocity is 0, so therefore our c is 0. And now that we have our velocity function, we can now substitute the time into the velocity function to find our velocity after that amount of time. So after 5 minutes, as you can see, 5 cubed minus 3 times of 5 squared minus 6 times of 5, and that should give you the answer as 20 meters per second there. Alright, so this is another question. Okay, so finding the distance traveled after 1 hour. So referring back to the other question. So once again, we have the velocity function, and we're going to integrate to a distance function this time. So because the question asks us to find the distance traveled in a specific amount of time. So we're going to integrate again. So so basically s of t equals to 0.25 t to the power 4 minus t cubed minus 3t squared plus of c. So when t equals to 0, s equals to 0, c equals to 0. Okay, I know the question didn't specifically say this, but if the question didn't specifically state a specific number that Kevin has already traveled, it's pretty safe to assume that it's starting from a fixed point, and the distance traveled in that amount. The distance traveled when t equals 0 is also 0. Okay. So basically, we'll have our s of t equation, and we know 1 hour is equal to 60 minutes. So we're gonna substitute our 60 into the equation. So that should give us our answer as a pretty big number. So 3,013,200 meters there. Yes, that's a bit unrealistic. So this brings us to the next question. Okay, so this is pretty unrealistic number. So we're gonna explain why the model. Well, the model as in that's when you see the word model, that's basically the equation. Okay, so explain why the model might be unrealistic for a longer period of time. So basically, what we're gonna explain here is you can either explain using the distance, or you can explain using the acceleration. Okay, if we use a model of acceleration, then we can you can see that the speed will always increasing. Okay, so just like it's always just gonna keep going up and up and up. So eventually, over a longer period of time. So basically, I did the calculation here, but in the exam, if it does come up this question, you don't have to calculate anything. Okay, but just for the sake of explanation, I've calculated that Kevin will reach the speed of light in 670.43 minutes, and that is extremely unrealistic. So this model, so for example, this model may only be used for a specific range of time, okay? Because as the time gets too big, then it's just going to be unrealistic. So have another example here. So Kevin now travels through a snowstorm. His initial velocity was 20 meters per second. The acceleration is a of t equals to negative 0.5 t, where t is between 0 and 40. So basically, find the distance traveled when the speed was 5 meters per second. Okay, so in this question, in order to find the distance, we need the time. Okay, so we need the time when the speed was 5 meters per second. Okay. So to find the time when am I doing? So to find the time when the speed was 5, we can just make v of t equals to 5, and we can solve for the time. And then we substitute that time back into the distance formula in order to find the distance traveled in that time. Okay? So we have our a of t, so we're going to integrate, of course, to find the velocity function. So v of t equals to the negative 0.25 t squared plus of the c. And you know that it tells you directly that the initial velocity was 20 meters per second. That's just basically telling you the c value is 20 there. So I'll also know that we want to find the time when the speed was 5. So our next step is substitute our v equals to 5 and find the time that we need, okay, to substitute back into our distance function, okay? So if we substitute 5 into the equation, and then we'll just solve for our time. And have a little typo here. It should say negative 0.25 t squared. I apologize for the typo, but so just remember it should say negative 0.25 t squared plus 20, okay? And if you solve this equation, so to solve this equation, you can just basically move the 5 to the other side and then make equal to 0, and then use your graphics calculator to solve for the t. So you should get your t equals to 7.75. And now we know the time, we can now substitute this back into our distance function to find our distance traveled within this time. So now we can find our s of t, so we integrate again. So s of t equals to negative 0.125 t cubed plus of 20t plus of the c. So basically when t equals to 0, s equals to 0, c equals to 0. It doesn't specify like what the distance was initially, so we can just assume that it's 0. So therefore, if we substitute our 7.75 into the equation, and we can just solve for the distance there. So if we solve this by just plug everything to a calculator, you should get your answer to be 96.61 meters traveled. Alright, so our next part of this topic is the maximum and minimum applications, okay? So basically in kinematics, a very common question is to ask for the maximum distance, or for example, the distance traveled when the velocity was at a minimum or maximum. So that's the most common question, is asking, what is the distance traveled when the velocity was at a minimum maximum? That's a very common question, okay? But it doesn't have to be velocity and distance. It could be any of the 3 variables, okay? So that's just an example of a possible question. Alright, to follow through with these steps is exactly the same thing as what we learned in the maximum and minimum. So basically, we're going to find the gradient function, and we're going to make equal to 0, okay? And if we make that equal to 0, we're going to solve for the time, okay? So in this case, it's not x, it's time, it's t, okay? So in this case, we'll just solve for our t value. And then once we find this t value, we can substitute this t value back into something in another equation to find for a different variable, okay? So just use this time to find any desired value. So for example, once again, this is just another example. I don't know why I put 2 examples in, but sorry about that. So find the acceleration when the distance was the maximum. So exact same thing I was saying before. So basically finding something when the other thing was at a maximum. I have an example here. So Kevin now travels to school. The distance from his house in kilometers at any moment can be expressed as s of t equals to 0.1 t cubed minus 0.4 t squared plus of the 0.5 t. Find the distance where his velocity was at a minimum. Okay, so looking at this question, okay, we need to find the gradient function for velocity. So the first thing that comes to mind here, we've got to find the velocity function first, and then differentiate the velocity function to find the gradient function for the velocity, and then make that function equal to 0 to find the time. Okay, so first things first, we've got to differentiate to find the v of t. Oh yeah, I have what you need here. So what you need, equation for distance, we already have that. And we also need a time when the v was at a minimum. So we're going to differentiate and find this time, okay? Okay, so I think I've skipped a few steps here for some reason. I have no idea why. Okay, so v of t. Okay, so you're just going to differentiate first to make your v of t. So your v of t would be 0.3 t squared minus 0.8 t plus 0.5. And then if you differentiate it again, you'll get 0.6 t minus 0.8 and then you'll make that derivative equal to 0. So basically, in other words, you know the derivative of v is a. So basically, in this equation, just making the acceleration equal to 0. That's in other words here. So I apologize. I don't know why I skipped like 300 steps here, but you get the rough point. Okay, so differentiate to find v of t, differentiate again to find v dash of t, and then make that equal to 0. So you should get your time is 1.33, and oh, so I do actually have that, but it's just in the wrong order, looks like. Sorry guys, so I done it in the wrong order. So differentiate to find v of t, so we have our answer 0.3 t squared minus 0.8 t plus 0.5, and we'll differentiate again to find out v dash of t, so we found that, and we found that, and we make it equal to 0 to find the time. Yeah, and then finally we're going to be solving for our distance. Okay, so solve for our distance is basically just putting this 1.33 back into our s of t equation. So we put this back into our equation, we should get that our distance traveled should be 0.194 kilometers. Yeah, and that should be our final answers there. Alright, so another example. So starting at a point, we'll call this point K. Kevin shuffles left and on cue, changes direction and sprints 100 meters to the right of point K. T is the time in seconds since the start of the journey, while the distance is measured as the distance to the right of K. So Kevin accidentally starts early, leaving him to have an initial acceleration of 0.2 meters per second in the left direction, and as a result, his initial velocity is 2 meters per second to the left, at a distance of 2 meters to the right. So Kevin has the acceleration of 0.03 t towards the right. So the question asks, what is the maximum distance to the left of point K? Alright, so now we can use this information to model an equation for the acceleration first. So you know that a of t, we have our a of t equals to 0.03 t plus of our c. And that's our c is our initial acceleration. It says here that it has an initial acceleration of 0.2 meters per second in the left direction. Okay, so in the left direction. However, we can also note down that our distance is measured at the right to our distance is measured as the distance from the right of K. So distance is measured to the right of K, but the acceleration is to the left. So therefore, we can determine that if something is to the left, then it's a negative. And then something to the right is a positive, because the distance is measured as the distance to the right of K. So for example, if the distance equals to 50 meters, then Kevin is 50 meters to the right of K. However, if the distance is for example, a negative 20 meters, that can also be rewritten as Kevin is 20 meters to the left of the K there. So basically just choosing how you modeled your equation, okay? Because the question specifically says that the distance is measured as the right of K. So when there's acceleration to the left, then it's actually initial acceleration is a negative acceleration, okay? That's because it's in the opposite direction of what the positive value is, okay? So when we back to our point here is to find the equation for the acceleration. So we know the acceleration is 0.03 t towards the right. So that means it's positive, okay? So as you can see, it's in the same direction as the what was mentioned in the question. So therefore, we can find our a of t first. So like I was saying, the acceleration to the right implies a positive, and if there's an initial acceleration to the left, this implies negative. So therefore, we can write our equation as a of t equals to 0.03 t minus the 0.2. And now we can integrate this to find our v of t, which is our velocity function, okay? So if we integrate again, well, not integrate, just integrate. So v of t equals to 0.015 t squared minus 0.2 t minus up to 2. So once again, why am I using minus 2? It's because as a result, his initial velocity is 2 meters per second to the left. Once again, this is in the opposite direction as the positive distance, which is in the right direction. So therefore, we're going to write our initial velocity as a negative 2, because it's in the wrong direction. So that is our velocity function found. And now, our next step here Our next step is to be finding the maximum distance to the left. So basically, you know that v of t is basically another way of writing s dash of t. So the derivative of s of t is v of t. So therefore, if you make our v of t equal to 0, we can find the turning point, which is also the turning points, the maximum and the minimum of the distance, and we'll just substitute v of t equals to 0 to find the time. So if we plug our 0 in, we can just put in our graphics calculator to solve. So plug into our graphics calculator, we solved. We should get our t equals to 20 seconds or t equals to negative 6. So equals to negative 6.67 seconds. Right, so we know that our time actually can't be the negative. So therefore, our t must be 20 seconds there. Alright, so now that we found the time, okay, so we can find the time, now we can go find the distance, okay? So once again, we have our v of t, we're going to integrate again to find the s of t. And if we integrate again, that should give us our s of t equals to 0.005 t cubed minus 0.1 t squared minus the 2t minus the 2. And once again, using the same logic, it's because the initial distance was 2 meters to the left. If it's 2 meters to the left and the positive is to the right, that means to the left it must be negative. So that's why I've written it as negative 2. Okay, it's very important you keep this concept in mind, just in case the question comes up similar to this style. So now that you have your distance equation, you can now substitute our t equals to 20 seconds, and then we'll be able to find for the distance. So we find our t equals to 20, and we're going to substitute that 20 into our distance function. And we should find that our answer should give us to be s equals to negative 42 meters. So I was initially saying that this negative 42 meters here, that can also be written as 42 meters to the left. That's because positive is to the right, as said in the question. So that means to the left must be the negative. And if it's negative, that means negative 42 meters must mean 42 meters to the right. So we're going to rewrite this as our final statement. So because s of t is the distance to the right, negative 42 meters implies that Kevin is 42 meters to the left. And that will be your final answer here. Okay, I do have a little bit of a bonus here, okay, for anyone who's actually interested. So it's just a few bonus questions, okay? Just leave all your answers down in the comments, okay? Okay, so using the last question as a blueprint, so we have 4 questions here. So our first question is, when does Kevin return to point K? So remember how he shuffles left and then he shuffles right. So when does he return back to the point K? How long does he finish the 100-meter race? So include that. When I say the 100-meter race, that includes the time that he used to shuffle left and the time he took to run all the way to the 100 meters. Okay. And number 3 is, why is this a maximum distance from the left of point K, but when the second derivative test is used, it shows a minimum? So for the last question, we found that t equals to 20 seconds. If we use the second derivative test on t equals to 20 seconds, it will come out to be a minimum. However, the terminology used is the maximum distance from the left of point K. So I just want you to explain why is it the maximum distance from the left of point K, and why is the minimum showing up on the second derivative test? Number 4 is why is this equation unrealistic for an extended period of time? So this number 4 is basically a giveaway, since I've already explained it earlier in the video, but just added it in there for the sake of having 4 questions, I guess. So like I say, comment down below your answers, and whoever finishes first, I will give them 2 Afghan cookies from the canteen. Okay, so not much of a prize, but I'm poor, so I'm broke. I don't have much money, so that's all I can afford. I'm sorry. Alright, so I have this final example. So Kevin is now playing some tennis. When he hits the ball, the gradient of the velocity is 4.8 when t equals to 2 seconds. At t equals to 6 seconds, the ball is stationary. Assume the ball starts from rest. Okay, so what does the question ask? The question asks to find the velocity function. Alright, so it's important to analyze what information you're given. You know that when our v equals to 0, t equals to 0, or t equals to 6. And that's because At t equals to 6, the ball is stationary. When I say stationary, that also means, as according to previous slides, I stated that when something is stationary, the velocity is 0. And also, I've given you the information that the ball starts from rest. And when I say starts from rest, that means when the t equals to 0, then the ball is not doing anything, so it's v equals to 0 as well. So therefore, we can come up with this statement. So when t equals to 0 or t equals to 6, the v was equal to 0. So therefore, this can actually be modeled by the parabola there, okay? So basically, we can say that v of t is equal to a, which is the shape of the parabola, we don't know that for now, times of t minus 6. So if I put t equals to 0, the velocity is 0. And if I put t equals to 6, the velocity is also equal to 0, no matter what, okay? And now we also have this other bit of information, which is the gradient of the velocity is 4.8 when t equals to 2. And we're going to use this information to find our a value. So when something says gradient of the velocity, that means we have to find the derivative. So we do that by expanding the equation first. Okay, so we're going to expand. And we should get that that expands to at squared minus 6at. And now we just differentiate very normally and we'll get the acceleration equation, okay? So we know that when the gradient was t equals to 2 seconds is 4.8, or the acceleration was 4.8 when t equals to 2. So if we find out a of t here, a of t. So if our a of t should come out to be 2at minus up to 6a. However, we know that a equals to 4.8 when t equals to 2. So we can just plug these numbers in and we'll find for our a value. So we can say that 4.8 equals to 4a minus up to 6a. So negative 2a is actually, negative 2a is equal to 4.8. So therefore, a equals to negative 2.4. And that's our a value. And that's going to be plugged back into our velocity function. And our final answer would be v of t equals to negative 2.4. Negative 2.4 times of t minus 6. And that will be your final answer. So I just have one last question. We'll finish by finding the maximum distance traveled by the ball. So to finish, we'll just find maximum distance, because why not? Alright, so for maximum distance, we need to make the derivative equal to 0. V of t is our derivative of distance, and we have already found, we actually already found this when it's equal to 0 from the last question. So we've already made v of t equals to 0. V of t we know equals to 0 when t equals to 0 or t equals to 6, okay? Alright, so now, okay, so we have our t equals 0 or t equals to 6 seconds. Following normal exam, you probably need to use a second derivative test to find which one's a maximum and which one's a minimum. However, since t equals 0 is basically when the ball starts moving, and it's pretty obvious. I mean, I'm not gonna say obvious, but like you can see that when t equals 0, it's when it's actually where the minimum is gonna be, okay? And when t equals to 6, that's where our maximum is gonna be. But that's just me being lazy. But like, if you're coming to an actual exam, just use the second derivative test no matter what, okay? Use the second derivative test to prove that t equals to 6 is the maximum, and then put it in, okay? Just because for the sake of me being very lazy, I didn't do that. But just so you know, you should be doing that in the exam, okay? Don't be like me. Don't be lazy. Alright, so we just solve for t equals to 6. So we have our v of t equals to negative 2.4t squared plus a 14.4t. That's just basically substituting a equals to negative 2.4 back in our previous equation, because we already found that a equals to negative 2.4. We're going to integrate to find out s of t. So if we do that, we'll find s of t equals to negative 0.8t cubed plus of 7.2t squared plus of the c. So once again, when t equals to 0, s equals to 0, so therefore c equals to 0. And our last step is just to substitute our t equals to 6, and we'll find our distance. So s of 6 equals to negative 0.8 times of 6 cubed plus of 7.2 times of 6 squared. And your answer should come out to be 84.4 meters. 86.4 meters, sorry. And that should be your final answer. Alright, so I hope that you enjoyed watching this kinematics slideshow, okay? I know I had a few sloppy moments. I got a bit lazy in some of the slides, but I apologize. But I hope you enjoyed nonetheless, and I hope to see you in the next video. Remember the bonus, leave your answer in the comments below, and first one to get all 4 questions correct, I will buy them 2 Afghan cookies. Okay? Peace out.